Hello, everyone. Welcome to the Offensive Security Club Custom Exploitation lesson. First things first, next slide, please. Please fill out the attendance at attendance.offsec.club. We have been having a lot of people show up and not actually fill this out, and I've had to go through manually. So take 30 seconds of your life to save my sanity because that's important. Moving on, we have some club events going on. So we have our weekly Try Hack Me's on Friday nights, 6 p.m. Central, in the same Discord that most of you are currently in. Links will be posted at moshpit.offsec.club. We'll also have things in the various offensive security channels. There are prizes now, so be sure to tune in and attempt to win some of those. We also have some people doing Hack the Box throughout the week. You can join Hack the Box, or even sometimes we post it in OffSec if people are working. I know we have Bailey has been actually streaming some of the stuff that he's doing for retired Hack the Box boxes, and I think he's going to start archiving some stuff on his Twitch, which is linked on the slides. You can get to the slides by the link in the top right that will be there for the entire night. We continue on a little bit more. We have Noob to Root is still going on, specifically the Boot to Root phase. I posted a new OVA early this morning that will work in VMware Workstation or Fusion. It also shows the IP on the login screen and patches some issues people were having with certain services, specifically the HTTP website. So due to some of the issues, we're extending the points deadline to Friday at 12 Central, where we will also have a walkthrough going live on our YouTube at that time. And then obviously we are still around to help with questions. If you have anything specifically on the OVA, come see me, because that is the new OVA specifically. I am the one that made that, so let me know if there are any issues with that. More updates. CPTC, we just learned that the team, which I put on the slide again, will be competing at the Northeastern Regionals on 10/31. So we're super stoked about that, and can't wait to share what progress we make throughout that. And moving on more, we still want to hear your feedback on what topics you want to see in OffSec. Do you want us to go more advanced? Do you want us to stay on a more beginner level? Please fill out the forum at topics.offsec.club. Next week we will be going over red teaming for competitions. I'm going to try and have a panel of people come in or just share some different methodologies if people can't make it. The week after that starts our redacted series, so be ready for that. But just fill out that form. Please don't spam 50 meme submissions that I have to go clean up. Actually put something in there that's useful to me. Yeah, so I think I have one more before you, Jared. Yeah, so some current events for this week. The United States Cyber Command took down the TrickBot botnet, or severely inhibited its abilities to perform all of its tasks. The General Nakasone said that his top priority is for a safe, secure, and legitimate 2020 election. There's a lot more details at that link or other links around the internet. There was also in Fairfax, Virginia, there was a data breach of several hundred employee SSNs. I think that's still an ongoing developing situation, so more info at that link if you're interested. And so with that, I will go ahead and turn the floor over to Jared to talk about custom exploitation. As a reminder, you can submit questions throughout the presentation at questions.offsec.club, or put them in like the Computer Club's Discord chat, and I'll try and relay them as needed. So Jared, the floor is yours.
Perfect. Thank you, Tristan. Okay, so today's kind of going to go crazy fast. So, it might be in your best interest if you see something that you really like to go back to the VOD and rewatch it. I put a disclaimer. Like, a lot of these topics and elements that I touch on really fast are going to be learning points within Temple of Pwn. So if you like any of this, Temple of Pwn is a club that I think Logan and Andrew started, that is basically going to do all of this stuff, but teach it way better, and it's going to be like super in depth, and it will. It's just going to be like a super great learning experience. So if you like any of this, be sure to check out that. And then if you enjoy any of the Ghidra scripting that we do, um, stay tuned because I'm making a repo that will have a bunch of walkthroughs. There's like probably like 2 or 3 guides on how to make a Ghidra plugin that are actually extensive enough to be effective. And so, and I've done it for quite a while now, and so I'm making a repo to make it a little bit easier, and then I'll kind of link it out once that's done. If you like any of that at all, because you might hate it too, because it's all Java, and so if you hate it, then just don't do it. But if you really enjoy watching it and you might want to do it, I'll have a cool repo soon. Okay, so we're gonna fly through the slides because I think um, I think the um, demo that I'm going to show off will be a little bit more like interesting to watch. So the slides will talk about methods of exploitation, defense mechanisms, some tools. All these tools we'll be using here, and then an example from the CTF we did 2 weekends ago. And then if there's any questions, we won't do another example because it just takes too long, and I don't want to hold you hostage for too long. Okay, so these preliminary slides are like they'll be covered so much more in depth if you're super interested in learning about them if you go to Temple of Pwn. Like every single one of these elements will be talked about like in way more detail than I could get in one meeting here. And so again, if you're super into this exploitation stuff, you should be sure to join the Temple of Pwn Slack channel and then join us every Saturday. Because it's like a fantastic time. And there's like not many people, and I think there's way more that are interested in it. So if you like this kind of stuff, you should join. Okay, so methods of exploitation. Um, there's a few things that can happen within produced binaries and applications that can make users and administrators vulnerable um, to certain kinds of exploitative attacks. So sometimes attackers can take advantage of poor code practices. So sometimes, like if you don't know what you're doing, or if you're using a function that's actually curtailed to be used very specifically and you use it more broadly, then maybe an advantage can be taken there. Or outside memory leaks, maybe they have permissions to read the memory file that all of the pages that are mapped to your current running process, and that leak is enough for them to return somewhere that they shouldn't return to. Maybe you're using something like libSSL or OpenSSL or something that has a vulnerability that's been compiled in, and then when you link the library, maybe there's a vulnerability that lies within it. Or maybe there's something that you're checking, but you're not considering the element of time. So maybe they could slow down. They could do something like a side channel attack, slow down the process speed, the processor um, instruction speed, so that they could get in and do something between 2 checks. Um, and do something that they shouldn't be allowed to. Some of these are like really advanced, like race conditions usually happen within kernel exploits, and like library implementations will usually be patched like relatively quickly if they're found to be pretty harmful. But poor code practices and memory leaks and things like that will happen a lot, and that's where uh, some of this will dive into. Method examples: buffer overflow, ROP, custom shellcode, stack heap spraying. Got we talked about this a couple weekends ago or weeks ago, um, when Logan was talking about the intro to CTF. So if you haven't seen any of these things, then you can go back in the VOD and look things up individually. Defense mechanisms. We talked about this then too. And so if any of these things don't seem like you've ever seen them before, I would just research them on the side. They'd probably do a better job of explaining. Okay, so the difference between this talk and what's been shown before is that we'll leverage Ghidra we'll leverage Ghidra's scripting agent to like perform tasks that we want it to perform. And so Ghidra offers a lot of like backend capabilities. So it has a flat program API decompiler. It has a disassembler for like basically every known architecture. It has P code emulation. So there's like lots of opportunity for us to leverage what the NSA developers wrote millions of lines of code to do, and then we can just utilize the scripting API and maybe even the plugin API to like do way cooler things. Because sometimes it's difficult for the NSA to know exactly what exploit developers are looking for, especially in like the public space. And so, they just give you the opportunity to script out things that you might be interested in scripting out. And okay, so we'll go right into the demo. All those slides will be available, but I don't know how helpful they'll be. Um, what's the NSA? The NSA is the National Security Agency. Okay, so a lot of this will probably fall apart extremely quickly because I installed Ghidra extensions into Eclipse and then uninstalled them to attempt to make this work. So that might make it all fall apart, but I've got a good feeling it'll be good. So I'm first going to. I mentioned before how you may want to um, go and get Ghidra set up and get Eclipse downloaded. The reason that Eclipse is really nice is because Ghidra wrote their own, um, like the developers at NSA wrote their own um, extensions for Eclipse to like port into what's called a Ghidra dev environment. And so, like all of the autocomplete features, all of the syntactic checkers, like there's lots of things that are written into Eclipse to help you utilize a lot of the Ghidra APIs. Um, and that has some downfalls because that means you have to use Eclipse, and like Eclipse is like pretty hefty. It's like extremely process intensive, and it also like kind of forces you to pick. Well, you can write scripts in Python, but the Eclipse IDE won't give you as good of Python support, and so for the most part, it's recommended that you write everything in Java, which is actually okay because when you write your plugins in Java, you actually have like access to the entire JVM that Ghidra's running in, so you get like so much more control over everything that's happening. So if you're interested in following along with any of this, I'd get Ghidra installed, Eclipse installed, and then I think you need JDK 11. Ghidra won't run without JDK 11, and Eclipse will be really upset if you don't have JDK 11 too, or any version of JDK. But just make sure you have a development kit. Okay, so all of this will probably be hard to follow along with. So I would say if you're wanting to follow along, just look back at the VOD. Um, okay, so fresh Eclipse install. If you want to port in Ghidra extensions, you go to Help, Install New Software, and then we'll add a new archive, and that archive is from our Ghidra install directory, extensions, Eclipse, Ghidra dev, and then Ghidra dev.zip. So this archive basically holds all of the extension data needed for Eclipse to understand Ghidra um, scripts and Ghidra plugins. So we'll pick that one. We'll say next. It'll probably fail because that's how live demos always work. I accept. Holy cow, that was crazy. Okay, so after installation, we'll need to restart. Oh my gosh. We just go with it anyway. Okay. So the reason you have to reboot is because it has to hook into like where you have Ghidra installed. Because Ghidra's Slay developing, yeah, we'll be fine. So like the way that Ghidra decompiles things and the way that it disassembles things needs to be hooked in with Eclipse so that it can like understand. Like both of them are kind of like working synchronously, and now when you compile things, you can build it right into a Ghidra environment. Okay, so we've got this thing called Ghidra dev. We'll make a new script project. Basically, uh, building things into projects is really nice because it stores like your working directory, your paths that you might need like continuously. What else is nice about it? You can reference scripts within your scripts, which is really nice because scripts just have one function called run, which is just an override. And so you can like call and invoke other scripts that are within your project. So we'll call it demo, do all those things. This is where you actually hook into your Ghidra instance. So we've got to go back to home, Ghidra, and then you can just pick the home directory. Apply and close, finish that up. Holy cow, I can't believe it worked. That's like 1 out of 5 working. Okay, so Ghidra is like, there's a lot of flack given to Ghidra. Well, there's like Ghidra gets hit pretty hard for not like disassembling things in what seems to be as nice of a format as what IDA does. But Ghidra's like scripting support and its decompilation are like two of the greatest things that have ever been invented in life. And it goes like The Office and then Ghidra extensions. and then like that's just the only two good things that have ever been invented. And so within here, they give you like a bunch of demos. Like this is like, well, actually, this isn't a very helpful script. Oh my gosh, that color scheme is terrible. I don't know if I'll know how to change that. We're gonna try to though, because I don't even know if you can read that. Can someone unmute and tell me if they can read that at all?
I cannot read that at all.
Oh my gosh, we found something. Basic? No, that's not what I want. What do I do now? That's not what I want. Okay. Sidebar. Eclipse color theme. Classic. Syntax coloring. Oh my gosh, this is not what we want. No, we want just oh, look at how bad it is. Okay. Switch to light theme. First time in my life I want to go to light theme. Help, Eclipse Marketplace, color themes. I don't want that. Oh my gosh, we found it. Okay. Window. Oh, oh my, it's already dark. Classic. That's not what I wanted. Holy cow, this might be a ruiner. High contrast. People be able to. Oh my goodness. Is this picking by default dark theme?
What about the colors and font theme right under it? The window.
Oh, here. What if I did this? Wait, that didn't change it. Yeah, what did you say? Go like a classic? Classic? Oh, yeah. But it's not even changing. Holy cow. Enable theming. Oh my goodness. I can't even read it. Okay, this is a new idea. Just absolutely changing the game. Somehow we'll have to do this without syntax highlighting, but you gotta do what you gotta do. Nope. That's not. Don't look at that. Can't even copy out. Okay, any other ideas on appearance?
You can use Control-Shift-C to copy out.
Yeah. That's in my VM it should just be able to copy out, but I uninstalled VMware tools. That's okay though. Okay, don't worry about this yet. We'll come back and we'll come up with a way to do that. Okay, so we've got that implemented. And so we could go into our Ghidra dev. We can make a new Ghidra script and we can apply it to the same folder that we've started here. And so usually you just go into home scripts. This is like the home directory for new skips. We'll call this the demo ROP finder. And it'll be written by me and it'll be exploit development. Helps developers find exploits. Oops. Perfect. Okay, so actually, as I do a line, you might be able to read it. You just can't read the whole thing, which is like the most unfortunate. I don't even know why they did any of this. That's okay. Each time we do a line, you just go off that. Okay, so the goal of the script that we're going to write is to help us find ROP gadgets that we're interested in when we go in and exploit the program that we're going to exploit. And I'll put all of the code we write and the binary that we're exploiting into the Slack channel so that you can play around with it after. So Ghidra's scripting API has this really nice like set of given parameters. So you've got things called current address, current highlight, current location, current program, and current selection. And these 5 elements like tell you where you are within Ghidra. So if you're like hovering over something and then you want to run a script against what you're highlighting, then this will return a program selection. If you're like arrowing down and you're like at a location, this will return a program location. Whatever program you have opened will be your current program. Whatever, like if you have a variable selected or function selected, this will return a program selection. And then address is just the same thing, except it simplifies it and converts it into an address type with which Ghidra defines for itself. So what we want to do to start is make some sort of assembler for ourselves. And I'm doing this instead of using the Ghidra disassembler because it's in this script format. We're going to keep it super simple. And we're going to go string to string. Oops. And we're going to call it the simple assembler. And that's going to be super simple. So Eclipse is super nice. Any errors, you can just hover, and then it'll like let you know what your import error is. You can just fix everything. I don't think I've ever fixed an error myself. Like I just let it figure out what I did wrong. Okay. So we oops, I didn't mean to click that. What happened to my cursor? Holy cow. Is this actually just broken? Okay, we're gonna unselect, then go back in. Oh, we got it. We're back. Okay, so what this assembler will do is it will convert the string gadget we input into bytes that we're looking for. And so the first thing we want to do is add a conversion that we know we're going to need. And so we're going to put pop RDI in here. Does anyone off the top of their head know the hex value? Okay, that's okay. You'd have to unmute. That's a lot of work. So pop RDI is 5F. And so we'll do that. We can just copy this down. And we're going to get a ret also. Does anyone know ret? Oh, I already started it. It's C3. So basically what we're doing here is we're simplifying the way that we'll grab gadgets by our search command. And so this is just going to take whatever our command is, parse out what the instructions are that they want the gadget to include, and then convert those to the hex bytes that we should probably be looking for. And if you want to know a really great place that you can figure out these for yourself, you can go to diffuse.ca and then go to their assembler. And then you can say, like, I want to know what pop RDI is. And then you can assemble it and find out what that hex byte is. So if you want to like write your own conversion or your own simple assembler, you just use these things and reverse it all. Okay. So we've got both of those down. So next, we want to come up with a way for us to get a string from the user to define the gadget that they're looking for. So we're going to create a string called the gadget string, and that's going to be equal to ask string. Ghidra and the Ghidra scripting engine has this really nice set of, oh my gosh, no, I didn't. You freaking pranked me. I swear I thought I did. Okay, notifications, nothing. We did it. Called ask, and then like a variable right here. So like they've got ask string, ask address, ask byte, ask choices, directory, domain file, and then there's one called ask program. Basically, all of these are ways for the JVM to like super easily interact with the user without having to require like new models for the text box to be created and then an input box to be defined within that text box and things like that. And so we can just ask string, and this will just say gadget string, and we'll ask them what gadget do you want. Perfect. Okay, next. We need to parse out the gadget string into instructions that the gadget would actually contain. So we need some sort of way to parse this by semicolon. So we'll say that the gadget parts is equal to gadget string dot, and then we're going to split on semicolons. Basically, this is just saying if we had like, let's say we had Like I want pop RDI, and then I want pop RSI, and then I want a ret. Like we want all of these to be included in the gadget. And so we need to make sure that we parse on this and then eliminate this white space too that comes between the parse. So we'll split up what their gadget string includes, then we'll walk through it. So we can do something like var gadget within the gadget parts. And then we'll say something like, oh, let's first make our byte string. So we're going to call our gadget bytes. This is just going to hold on to the byte string that comes from our lookup on our assembler, because eventually we're going to query for a byte string of bytes, and we're just going to set this to nothing. So next we want to see if we can actually find the string that occurs. So we'll say something like var temp is equal to our simple assembler dot get based on what our gadget is. And we're also going to strip the gadget just to make sure we don't get any new lines. Then if our temp variable is equal to null, hash maps are really nice. They won't like error out if you don't have a successful lookup. They'll just return null back. And so we don't have to like wrap this in a try catch. But we have to check if it's null. So if it's null, that means that we didn't find one of the gadgets. So we didn't find the gadget needed. And then we'll just break out of this. And we should probably have some sort of int fail equals 0 to see if we failed to look this up. Okay. Otherwise, if we did find something, then our gadget bytes plus equals our temp, because this temp is going to return the byte string that we need, which is defined up here in these two. Okay. That was all really fast. Next, the final part, we just need to attempt to get bytes. So basically what this, we need to find bytes. So find bytes is a flat program API function offered by the scripting engine that can walk through an address start and then try to find a byte string that you're looking for. So we basically can just give it a start and then give it a byte string. So we're not going to give it the current address because it could be anywhere in the program. Instead, we're going to give it the base address. And then this byte string is actually just our gadget bytes. Okay, now this returns an address. So we can say something like var outer equals this. I think it returns null bytes if it's not found. Oh no, I think it. I thought it actually returned more things. Like I think you can get it to return an array of addresses. Let's find out. So really nice feature of Eclipse is you can just control space and it will like give you the number of things that you can finish. So like this version of the function, so like with parameter overloading allows you to give a match limit, and then that can like determine the maximum sized array that's returned back to you. So we'll say something like, we'll give it this address start, we'll give it the byte string, we'll give it how many limits we were okay finding, and then we'll give it alignment. So this is actually a little bit more appropriate to what we want, because we might want to return to the programmer that there's a number of places that they could get this gadget from. We'll say they can return 5, and we're going to make the alignment 1, because we actually don't care if it's correctly byte aligned. Okay, so our addresses are here. So now we just want to say if the address is dot length, oops, if you can spell, length is equal to 0, we're just going to tell the programmer no gadgets found. Oh, also here we could say something like if fail, print, we'll do, oh wait, actually we could totally just do this. We don't even have to do this, we could just return. This is actually running in a function that's just overridden, so you can return back to what you want. Okay, that's good. Else, we'll walk through these addresses. And we'll print them out. So we'll say something like found gadget at, and then we'll say 0x. Okay. Are there any questions on that? I accidentally took away the questions. Oh, you can read it if it's zoomed? Okay, cool. But then someone else said it looks like garbage. Cool, thanks. Okay. We won't need to do that anymore. Okay. Any questions on what we just wrote right there? Like, this color scheme is actually terrible, but I'm not smart enough to fix that. I guess I could do this, and then you could maybe... That's just disgusting too. Okay, so we want to confirm that this works, so we can build it right into Ghidra. This like starts an entire JVM for Ghidra to run within, so you can actually like interact with Ghidra just like you would normally. And so there's like no like limited features. Sometimes you'll boot off of this, and then you can continue to do a lot of work. Ghidra will save your running project, and then you can still make changes to your script afterwards. So we'll import the file that we're working with. So that's within school clubs, that, and within custom Canary. So we'll import this. We'll auto analyze just so that it finds functions that are already found. Really interesting feature too. Eclipse will have like output based on the running instance of Ghidra. So like if you're importing something and it's not working, you could actually build it in Eclipse, and then it'll give you way more appropriate output. Okay, so now in Ghidra we can save all this. To get to this the script manager, you just go to this play button, and we'll make this bigger. I don't know if you can zoom on Ghidra. I'm really sorry if you can't. I don't think you can. You just go to this really big play button on the top toolbar, and then you can search for your script. So we called ours Rob something. Demo Rob Finder. So we'll search for that just so that it's easier to find later. Then we can run it. First thing it does is asks us for string. And so it's asking us what gadget we want. We can say we want pop RDI. And it says it found all these gadgets at these locations. Ghidra's super nice. You can double click on addresses and it'll bring you to it. If it's like space delimited. So if it's got spaces on both sides or white space on both sides, you can do this. So every single one we go to, we see that we've got the 5F hex bytes. Holy, I wish I could zoom. I'm sorry. Let's see if I can. I thought I was just Ghidra wizard, but I don't even know how to zoom. That's okay, you'll just have to squint. So every single time that we go to one of these, we see that a 5F is actually at the location. So we're doing something right. So we can go back. It has a really cool button that just reruns the last script. We can change this to say pop RDI ret. See if we find any of those. Okay, this time we only found one. So we can go to that location. We see we've got a 5F and then a C3, but it's actually in the middle of an instruction. So we actually don't care about that at all because we could just return to this offset, which it gave us here, and we'd be good to go. So I'm going to make note of that for later, and then we'll go into the actual exploit. So that bad boy goes in the pop RDI gadget. Okay, so while we're in Ghidra, we can start to analyze the binary that we're trying to exploit. So this was given as a challenge at the Clemson CTF 2 weeks ago. And basically the premise is that the programmers compiled without a canary. And so you can overwrite the stack canary that's defined each runtime. But the issue is that the compilers put in their own custom version of a canary. And so the point of the challenge is that you're supposed to reverse the method in which they're creating their canary so that you can predict what the method will be, write it for yourself, and then based on the time that you run it at, you can predict the canary, write it into that spot, and then still overwrite your um, and get an exploit. So first thing we'll do is go to functions, find what appears to be a main. We can probably run the binary first to see if maybe it gives us some string indicators. So it's asking for a custom canary beta test ID. One thing that you can do that's kind of nice is you can go to window and then, or you can go search and then search for strings, and then we'll find where that string is. So, all right, um, here we go, beta tester ID. I kind of wanted the other one. I'm surprised. Oh, I guess it is this whole thing. So wait, it's actually not even here. Oh my gosh, that was annoying. Let's show references. Okay, I don't even know what. Oh, so I think maybe the TM character is running the string finding. That's probably happening. Ghidra's not actually entirely robust. But instead of doing that, since there's so few functions, you can just walk along these and try to figure out which one's important. This one's one that we're probably interested in watching, because if we get into this function, that probably means that we failed to find the correct canaries. This looks like a canary generator, so we can just rename this Canary Generation. What else do we have? That looks unimportant. This probably looks like main. So we'll name this to main, and then we'll try to figure out what's going on. So, yeah, I think that there was an issue with this finding the string just because the trademark character is here. And so, no, I guess it did know it was a string, but then there was probably some sort of Unicode character, like right here and here, that broke it a little bit. So it reads in some input, no limit on the scanf. Then, oh well, this is actually just reading your like ID for whatever this piece of software is supposed to be used for, and then checks if your ID is less than 65, which is 101. So it confirms that you give an ID that's greater than 101. Calls Canary Generation 2 times. So it looks like it's probably creating 2 canaries, setting them at these data locations that are null to start, and then offering you the opportunity to bypass the canary. Then it's got this function that's doing an fgets with 80, which would be 128 bytes. That sounds about right. And the buffer is only 64 bytes. So it looks like this is probably where the overflow happens. So we'll say this is our buffer. This is vuln. And then we can see the 2 canaries are loaded in here. And so in 2 local vars that you would overwrite if you were to smash this buffer, 2 canaries are loaded that were created at the beginning of the runtime. So it looks like, and this is probably that print out if you failed message. Yeah. So we'll just say this is L. Well, this is just stack canary fail. Okay. Also, you can press Alt left if you want to go back in Ghidra, and you can go Alt right if you want to go forward. Okay, so first things first, we probably need to come up with a way to beat the canary that's being created. So if we smash, oh well, we'll give it a valid ID, and then we bash it a bunch. Oh, we need way more. Oh no, we'll just do this. Then we get the Stack Overflow message, so it's pretty broken. But we still get like actual. I think it actually just exits from there. I don't think it reads from there. So first thing we probably want to do is come up with a way to beat the canary, and then we can start working on our exploit. So if we go back to our main which called here, we should go to Canary Generation. This parameter is your ID, and then this is probably going to be cur time. If you see like a time t var, that's Ghidra predicting that if a time function call is made, that a time t type will be returned. And so Ghidra's pretty smart of looking like in the future. This is just a time null. parameter. And so it looks like it's using the time and your ID to create something. So we'll go in. Let's start. I've got this backup Python exploit. So if anything breaks, we'll still have a good demo. So we're going to make our exploit. We talked a little bit before about pwn tools. So I won't go too deep into all the things that they can do. If you're super interested in pwn tools, you can come to Temple of Pwn because Logan knows how to use it really well, and so he can show off a lot of things. We'll also need to import time, and that's just because we're going to start the exploit, and we have to also get the epoch time that the binary's getting. And so it's best for us to just calculate time for ourselves at the exact same time that we start the binary, so that we can calculate this properly. So we'll say cur time equals time.time, and I think it's like, I think that it actually doesn't return an int. Here, let me make sure. That's not what I wanted. I want the way bottom. Now I'm all over the place. Holy cow. Time.time. Yeah, we're good to go. Okay, so I just don't even need that. So we'll say that our current time is time.time, convert that to an int so we know we're good. And then let's look at the rest of the canary. So it looks like it's taking whatever our ID is, modding it by 10, adding the current time, subtracting our ID mod 100, modding by 640, and then multiplying it by 8. And then it's dereferencing that plus a function that's already defined in the data section, which is this exact size long. So basically what it's doing is it's taking a pointer that points to data section of just like random data, and then it's creating an offset based on the time and our ID, and then it's walking into that offset bytes and then taking 8 bytes and dereferencing and storing that into a canary. And so something that's kind of interesting is that every 8 bytes is a null, which is pretty consistent with how canaries are actually generated. So what this is doing is basically picking from a list of 640 canaries and then picking one at each and every single runtime. So we can take this math and copy it basically verbatim and recalculate exactly what it's doing. So we'll say that our first canary, or we'll say our first offset, is equal to, and we can just make our ID 101 because we know that works at least. Oh, I think 102 will be better. So 102, and we'll say it's 102. Oh, we'll make it ID mod 10 plus our cur time minus whatever our ID mod 100 is, and all of those into one. Then we'll mod that by 0x640. I think 0x640 is just 1,500 or something like that. No, I think it's a little bit bigger. And then but basically it's the exact same size as the number of 8-byte canaries that would fit into the data section. So it maps perfectly with the problem. And we'll multiply that by 8. Okay. Next, we can create the second offset. The second offset is almost identical, but it uses ID XORed with a specific value. And so if we go back to this, what's calling Canary Generation, we find a function that's basically doing first generation based on our ID, second generation based on our ID XORed with 0xDEAD. So we'll copy that, and then we'll say SID equals 102 XORed with that, and then we'll basically just do the same exact thing here. SID. Okay, next. These aren't actually our canary values. These just give us offsets between 0 and 8 times 640. or 0x640. So what we need to do is find out what they're offsetting into. And so you could do a number of things. You could open the file itself and read in that many bytes, or read in the entirety of the file and then jump to that offset, which is what we'll do for this case. Or you could copy out the bytes from that data section, bring it in as a string, um, or as a list of bytes. Which, I mean, either way is relatively functional, but I mean, for the most part, it's probably easier code-wise to just read it in as a file. So we'll say that our file is this exact same file that we're working on. And so this, or on the canary that we're working on. So we're going to open custom canary for read. And then we want to read every single byte into this huge array. But we also need to know some things about the output, or about the offset. And so we know that the offset, given it's being loaded into pages in memory, is 0x4, 0 something something. But we want to know if it were just opened as if it were a file, where it'd be located. So we can go in to the Canary Generation, look at this, and like just thinking intuitively, it's probably at an offset that's like 20 bytes in, just because this is a base offset that's given when it's loaded into memory. And so we'll just copy that, hoping that that's right, but we'll go check just to make sure. So we're looking for into custom canary, and we'll pipe that to less. And we're looking for a few bytes, so we can look for 008449. 8449. We find it here at offset 2020. So we were pretty good on our prediction. Just that base offset that's given when you're loaded into memory, we can just dump that off, and this is where we're loaded. So we also only want to read 0x640 times 8 bytes, because we want 0x640 canary values. And so that's how many bytes we're going to read. Now we can actually calculate the canary. So canary 1 is equal to data at first offset to first offset plus 8. And then canary 2 is equal to data at second offset to second offset plus 8. Okay, perfect. So is that good? Are people a little bit like, does this canary creation make sense? Because we're basically just going to do exactly what the program's doing, but we have to open it itself and not load it into memory. And so the offset's going to be a little bit different. Okay, next. We need to figure out what this buffer size is, because we can now start to test to make sure that our canary creation is good. So to do it, a nice test, we can go within again, and we could say print, and let's say we wanted the hex value of the unpacked version of our canary 1, and let's give this a shot. Nice. Not enough, or too many. Let's see, 1 2 3 2 3. Yeah, not enough. Line 21. I don't even think it's 21 lines. Could be this, actually. Oh my goodness.
Canar one.
Oh,
and the last.
Canar 1, and I don't have another one of these. Look at that, 2 issues. Okay, so this looks a little bit off. It looks like hex characters and then an all byte, so we're probably, oh yeah, okay. So we created this offset, so we actually we didn't even do the first read. So let's just open this as a file, because we need to do 2 reads to try to get into this perfect offset. So let's just do an open. We'll read those 0x2020 bytes that we don't care about. And now we'll say our data is equal to f.read, and we just want these bytes after. If that makes any sense. Okay, so that looks like a reasonably good canary, ending in null bytes, which we always want. And so we're probably pretty set. Let's make sure that the other one looks good too. Because if either of these fail, then we're probably not going to get what we want. Okay, they both look good. Okay, next we want to find out what that buffer size is that we need to overwrite first. So let's go back into the function that calls, that actually lets us read. So we're looking for vuln. We'll just go over here and find vuln. So the buffer's 64 bytes, and then we've got the two canaries. Perfect. So we'll just go back in here. These we don't need anymore. And we'll say our padding is equal to a times 64. And so we'll say okay, it's actually time to start running this process and passing our input in. So we're going to say p equals process. This is all given in the first talk that Logan gave about what Pwn Tools lets you do. So if you're super interested in any of that, you can follow that. So we're going to, well, we don't really care too much about anything that's come in. So we just receive, I think it's just a line that's given. Then we can send in our ID. And so we've got to send in stir of our ID. Then we can just probably receive line again, I think. Yeah. So both of those we can just receive lines. And then we'll send line our first, our packed version of the Canary 1. And then our packed version of the Canary 2. Oops. And then we're just going to go to interactive to see what output we get. Because if it doesn't say that we ruined the canaries, then that means that we're probably getting the correct canary. Okay. Oh. Actually, why is it that bad? It might have. Oh, I definitely, these aren't even packed yet. These are unpacked. So let's go ahead and pack them. Just to make sure that they're integer values this whole time, because then it makes way more sense. And then we want, oh wait, no, we want to unpack these here. There we go. Much better. Yeah, it was a string there. Thank you. Okay, so we got a fail here saying that like the process actually ended and we didn't go anywhere, but we didn't get any output saying like you just crashed the canary, which is what happens if you came here and gave it like a whole bunch of crap. It says Stack Overflow detected. So we broke that part. And so let's go back in and move on to our next part. So we know that we've gotten back past the canaries. The only thing that we have to do now is figure out where libc is located at, and then we need to figure out what offset from that libc base our system's located at. So just in the convenience of saving time, I'm going to figure out these offsets for myself without having to like look up with libc lookup, just so that we don't have to do another element, so we can keep it pretty simple. You can use LDD to see which libc is loaded super easily. Let's open this bad boy up. Really nice way to find offsets is to do object dump -t and then the file you want, and then grubbing for your call. Okay, you actually have to do the right call though. Okay, and then not be in insert mode. There we go. Okay, so we've got this system at this offset, and then we can do the same thing for puts. The reason I'm doing puts is because if we go into GDB for custom canary and we start it and we look at the GOT, puts is an element that's within here. And so And we actually know the address of that too. We'll need to worry about that. So puts is something we want to worry about because if this gets resolved within the GOT, we can then subtract that off, get our libc base, and then we can find system instantly. Next thing you can do, not like this isn't the most popular way to do this, but you could do a hex dump -c on the version of libc that you're looking at, and then you can pipe this into less, and then you can try to find your bin sh. I'm pretty sure that it's on a new line in this case. Oh, actually, it might not be. Oh, I don't know actually. Here, we'll just look for. Oh no, it's not going to find that. Let's look for. There's a way better way to do this, but finding this offset anyway is pretty tedious. Okay, just kidding. We'll go back to this way. I'm pretty sure I passed it. I swear it was like, oh, there we go. We found it. Okay, so this offset, we'll come back to this page, but it's at about 18A156, something like that. So we know what our puts at GOT is. We're just going to call this GOT puts. So this is where we're going to want to like print in some way. And we can use the puts at PLT to do that. And so we can find that right here. Then we don't need to worry about anything else, except we want to know what the, let's get this copied in. Let's just get all of our offsets, libc bin sh, and we're gonna say that's 6, libc system, and we'll go back and requery for system. Offset is 48F20, so we'll grab that. And then last one, we'll call these the offsets so I don't mistake them. We just want this puts offset because then we can create the base when we print it out. So this puts is found at 766BO. Bring that in. Okay, so it's now time to build out the entirety of our payload. So we want to, we're going to make our new padding. That's going to be equal to padding. Well, we'll just say it's A times our 64 plus our packed canaries, just so we don't have to worry about these in the future. And then we need to add on what we want to return to. For this binary, it's actually off just a little bit, so we're going to put this return location twice. I actually don't know why that is, because the vuln function doesn't have any. I mean, EBP is sitting there on top. Never mind, that makes complete sense. The old base pointer is sitting there, so we can just pass in packed zeros. Okay, now we want to know where we want to return to. Perfect. We took notes. We've got this gadget that we've been waiting to use all day. So this pop RDI gadget, this is exactly where we want to return to. So we'll say we've got a pop RDI right there. So we're going to return back to that. And then we are going to, after the pop RDI, we want to pop into RDI this GOT at puts location, so that we can potentially leak the address that it was resolved that points into libc. And then we want to return to this puts at the PLT. I don't remember. I just called it. I called it GOT PLT. What does that even mean? We'll call it PLT puts. Okay, perfect. Then after that, we probably just want to return back to the vuln function. And that's just because eventually we're going to have to leak this address and then rep back in to know where we want to go into. So we can find the address just by looking right here. Oh, get back. Okay. So we can dump this send line here. We can dump this padding here because we recreate it. And now before we go interactive, we can p.send line. Oh, that's just the whole thing. We'll just call it payload. Okay, and we're going to go interactive, and you're going to see, hopefully, that we get some odd characters printing back before we get them printing back, requesting for us to put more input in. That's the hope. So we run Python. Oh, we actually failed the canary. Okay, let's find out why that happened. Okay, so this could be happening for a number of reasons. It could be the fact that we're doing this time too early. And so we're going to start the process instantly because this read might be taking too much time. I don't know if this is actually going to be the issue, but it doesn't look like it. So let's see. What we could have messed up on accident. We unpack from our first offset. We do all that well. Pack it in. Okay. Read in the file before time. Well, we get the time, then we start the process. And so the process should. Oh, wait. It's, yeah, okay. So we need to start the process, and then we need to send our string ID because it's waiting for us to give our ID. That's my fault. So let's create these, and then let's p.send line stir of ID. Oh my gosh. Okay, so now we can dump out this right here, and we can receive the 2 lines that have been kind of buffered there. We'll see what happens. Okay, cool beans. I guess we can wait until after this send line goes to get our time. Holy cow, this is unbeatable. Start the process, send in our ID. Our ID's fine. We get the time then. Calculate it. Open custom canary. Read in. Any other ideas? They can be not good too. Just so I can break up what could be happening. It could also be that our canaries are off again. Let's see what happens. We'll see if this is still good. See, it's still fine. Oh, I wonder if. Okay, let's just instead of doing this, let's put canary 2 here also. Okay, then let's put canary 1 here. Maybe I'm off on the buffer. No cigar. Um. Okay. So we're sending. Let's just pretend we didn't receive anything yet, and we redid this back to 2 and then 0. Let's go ahead and GDB attach here. Okay. Logan, how do you actually do that? I usually like sleep and then attach myself. Or am I just misspelling attach? I actually don't know. Oh, okay, thank you. We'll see if this even works. Okay, so we can print out what the memory is right now, and then we can compare it to what our print showed when we were over here. So we have this 860 crap. We can zoom in here. And let's find out what that offset is, where this is located. So DAT 069, this looks pretty good. So we're going to just grab that. Perfect. Ooh, is that right? 864BF 8023. Oh my gosh, it's so good. What else went wrong then? Oh, oopsies. We're just gonna kill. Let's try printing out the second one. Maybe it's the second one. Where am I printing? Okay. We'll give this like 3 more minutes of attempting to fix, and then I'll go to the working version. Yeah. Let's see if that worked. Okay, that looks pretty good. And then I think the other one's at A0 or something. No, I already forgot. 98. Okay, so that looks slightly different. Oh wait, no, they look identical. 8DCE, perfect. 52. Okay, so it's not that. So let's go ahead and figure out what it could be. Okay, so all of this is good because we get the canary correctly. Then we give it our buffer plus canary 1 plus canary 2. And then let's make sure this print is actually what we expect. That seems right. XOR to 0. That's okay. That all looks fine too. Let's make sure we're packing these again. Looks like we are. I don't know. Okay, let's just use a second window to see if what could be different here. And then let's less our backup. And go through all these amazing amount of bytes. Okay. So it looks like here we send the. Oh my goodness. Okay, so the reason it's wrong is because it's actually in backwards order, and so it looks like canary 2 is actually on top, and then canary 1. Okay, let's see if this does what we want. Oh, perfect. See, look at that. Just look at your own notes. Okay, so we got this crap back. So let's figure out what that is by reading it in and then unpacking it. And it should be what our puts offset is, or it should be our puts libc address. So we want to look at where we received at and what it looked like. So we're going to receive until we get something like this with a new line. Oops. and then we're going to try to grab in what we need. So libc puts is equal to, well, we're first going to receive until we get to something that looks like this. Then our puts is equal to p.receive. And basically what we're going to do is receive 6 bytes. And then we're going to pad on the more significant bits. So those are both null bytes. And then we're going to pack all of this. Okay, and so then let's print out what our libc hex of our libc puts. Let's make sure that the offset looks something like 6b0. Thanks. Wait, are you sure? I think we actually want to pack that. No, you're right. Okay, look at that, 6b0, perfect. So this is our offset to puts within libc. So, or that's our actual libc puts address. So let's just finish this off with one foul swoop. So we know exactly where we're at. We have this libc puts. So let's get what the libc base is equal to our libc puts minus our libc puts offset. System, or we'll say libc system, is equal to libc base plus our libc system offset. Our libc bin sh equal to libc base plus, and I think somewhere up here we've got the offset for bin sh. Oh, there it is. It was just right in front of me. Oh, well, we just can use libc bin sh. Libc bin sh offset. Okay, next we just need to recreate this payload and send it again now that we've got locations within memory that actually matter. So instead of returning to this puts and then this print, we're just going to pop RDI, and then we're going to pop in our libc bin sh string, and then we're going to return back into thanks. Where is that at? There it is. Perfect. Thanks. Then we're going to ret to libc system. So we're basically just going to ret to libc without even worrying about anything else. Okay, we'll send that line, and then we'll go to interactive. Oh my gosh, has that ever happened? First try afterwards. Okay, so finding that that reorder was a little bit difficult, and screwing up how to spell words was a little bit difficult, and making things like this look nice was kind of hard. But I hope that was at least a little bit interesting. I think that Ghidra has a lot more potential than people give it. Like within the plugin development realm, you can write your own providers. And like the Ghidra version tracker itself is a plugin entirely written by the NSA. And so if you want like a good base for how to write plugins, you can just go look at the version tracker, and it's really helpful. And then the rest of the exploit, pretty straightforward. If there was any confusion on any of what that meant, you can just reach out to me, and I'll let you know like what the things I flew by, what that's actually doing. Okay, that's all I have.